So this video is all about the difference between distance and displacement and speed and velocity. So we've talked a little bit about position graphs, we talked about velocity graphs, and we're kind of trying to understand the difference between these four terms. It's a pretty key thing to think about. So here's a video of me walking around the room, and we want to know, what distance did I walk? Well, how would we find that out? Well, pretty easily. We'd say maybe it is from here to here is 4 meters. And then from across the back from one side to the other is 1 meter. So if I walked 4 meters back, 1 meter to this side, 4 meters straight down, then back 1 meter again the other way, well, that means I'm going to walk a total of 10 meters. That'll be the distance that I cover. So pretty simply, distance is just how far did you move. So you think of it as like a Fitbit or your step tracker on your iPhone. It's how far something has moved regardless of the direction that it moved. So in that video, I walked 10 meters because I walked 4 back, 1 left, 4 forward, 1 right. So distance is just purely like a video camera recording the motion, doesn't care what direction we're going. What about displacement though? So again, same video, say I go 4 meters back. And I go 1 meter this way. Well, in the end, through the whole video, what was my displacement? So say we go 4 meters back, we go 1 meter over, okay, we go 4 meters this way, and we go 1 meter this way. Okay. Well, what displacement is displacement's all about the difference between where you start and where you finish. So in this case, I started right here, and this is my initial position. And is also my final position is in the exact same spot. So my displacement for this motion is actually 0 because I changed my position over the course of the entire motion by 0 meters. So I might have walked 10 meters, but I only displaced myself by 0 because think about it, what we've been doing with our videos, we've seen we have positive directions, we have negative directions, right? Maybe this 4 meters here is the positive direction. Maybe this 1 meter here is the positive direction. But here we have a -4, and that would mean that this would be a -1. So all of those measurements are going to end up canceling each other out, meaning that my displacement, which we're going to find is this delta x, meaning change in, is going to be final position minus initial position. And in this case, since my final and initial position are the exact same, my delta x for this motion is 0 meters. So displacement is the difference between the start and finish of the motion. It's a change in position of the object. In terms of that change, you're going to subtract the final minus initial. So if instead of buying a Fitbit or an Apple Watch that tracked your motion all the time and tracked your steps, buying a displacement watch, you'd walk around all day. Maybe you went running, you did like a 3-mile run. Maybe you played a game of lacrosse, or you played, a game like 3 games of pickup basketball and stuff. You run all over the place. You did so much exercise. But if you had a displacement watch, when you left your house and then when you came back to your house, your watch would read a big fat 0. Okay, you would have no motion because no displacement because, well, you started at your house and you up at your house. So if your displacement for an entire day from your bed back to your bed at night is 0. Granted, you're moving all the time. Yes, we know that. But if we took a picture of you before and we took a picture afterwards, it looked like you hadn't changed. So difference between the two, kind of in summation, distance is about how far an object moves regardless of direction. Think of it like a step tracker video following your every step, and can only be positive, has no sign to it. Okay. Displacement, however, is the difference in the start and finishing position in the motion. So you think of it as taking 2 pictures, one at the start and one at the end, and then comparing the difference in position between the two. The sign will indicate the direction that it's going. Okay? So the formula for just the x-axis would be the displacement is equal to xf minus xi, where again, delta x is change, for those of you that don't remember from your slope formulas in math class. And to find change, you just take final minus initial position. Okay, so we got through distance and displacement. We hopefully understand the difference there. What about speed and velocity? How can we compare my speed and velocity in these two videos? Okay, so you see me walking around, same videos before, and then you see me running around in circles around the desk. Okay, how could we compare speed and velocity? Well, speed is very similar to distance. It's independent of direction, and simply the rate at which distance is covered. So in this first video, we know that we walked around that box, okay, and we said it was 10 meters. The distance was 10 meters, okay? And say, I think I did this in about 10 seconds. So that would mean my speed for the first one would be a total of 10 meters in 10 seconds, or 1 meter per second. Okay. The second video, the distance is the same. The distance is still 10 meters. The time now is cut in half, so it's 5 seconds. So our speed would be the distance over the time, which would be 10 meters over 5 seconds, or 2 meters per second. Great. Okay, so we're about twice as fast in the second video. Okay. Again, that's irregardless of direction. We're talking about distance over time. How far did you go? How long did it take you to get there? So speed, direction doesn't matter. Again, it's a rate of distance covered in a given amount of time. So it's kind of like taking the number of steps you complete and dividing how much time you took to do it, how much time it took to do it. Velocity, though, is different. Velocity is not independent of direction, which we've seen in our motion detector activities. Velocity is the rate of movement in a given direction. Therefore, it can be positive or negative, okay, if we're staying on one axis, which we're going to do in this case. So how do we find our velocity? Well, velocity is the displacement over time. So it is the rate in change of position over time, or delta x over t. So you can think for the first one, again, we know we go back 4 over 1, down 4 over 1. We have the plus 4, we have the plus 1, we have a minus 4, we have a minus 1. Well, for the first video, my v, which is delta x over t, is going to be 0. And it took 10 seconds to do it. So my velocity is actually 0 meters per second on average. For the second video, our delta x, well, it's still 0, right? Doesn't matter that I'm running, I still started and finished in the same spot. So we have 0 meters. Now it's only taking me 5 seconds. Well, guess what? My average velocity is still 0 meters per second. Now you're thinking, how is that possible? Well, here's how it's possible. Just like we had positive and negative directions, we have positive and negative velocities, okay? The velocity going maybe straight back might be the positive velocity. That means it's going to be canceled out by the velocity going this way, which is a negative velocity, just like it was with position. Okay? Even so, those two velocities on average will cancel each other out. All the time I spend going to the left here, that velocity might be positive. Well, it's going to get canceled out by the velocity going to the right. So all of those changes that I made to my position in the course of the motion get canceled out by the fact that I went the opposite direction at when I get to the very end. Now, granted, I do have a positive velocity when I'm going back this way. I do have a negative velocity when I'm going this direction. I do have a positive velocity when I'm going in this direction, right? I do have a negative velocity when I'm going here. It's just that overall, an average for the entire motion, those positive and negative velocities are going to cancel each other out, just like they did with the displacements. So, velocity direction is given by the sign, which we talked about and seen. It's the rate of position change in a given amount of time. It's not the rate of distance covered, it's the rate of position change, meaning that it can be positive, it can be negative. So it's kind of like taking two pictures again, but having a timestamp. And then you can find the change in position using that change in position and dividing by the difference in time between the two pictures. So hopefully that makes sense. Let's put it into practice with a graph. So here's kind of a graphical example. We want to know what distance did this object travel. Well, this object started at the 1 position and ended at the 5 position. So, well, they're going to go a distance of 4 meters. That makes sense. What about the displacement for this object? Well, that's going to be delta x equals xf minus xi. And our final position is 5. Our initial position is 1. So our displacement is 4 meters as well, which makes sense. The reason they're the same, well, we're counting this direction as the positive direction, right? Since we're getting more and more positive, the signs are going to be the same for the distance and the displacement. How about the average speed of this object? Well, speed is just distance over time. So we covered 4 meters in 5 seconds. So our average speed is going to be 0.8 meters per second. Okay, cool. Now, average velocity for this object. Well, velocity is delta x over t, and we found our delta x is 4 meters. Our time is 5 seconds, so we have an average velocity of 0.8 meters per second as well. Again, because all the direction is in one motion, those distance and displacement in the positive direction too, the distance and displacement are going to be the same. The speed and velocity are going to be the same. Okay? If we start changing directions, that's when things are going to vary, and you'll see that through the homework you do. The last part is, what is the mathematical model for the motion? Well, the mathematical model just means what's the equation. Okay? What equation represents this data? Which is pretty simple, right? Our position is given by a line, so y equals mx plus b is the line. And we know what m and b are. Okay. So, sorry, this should be y equals mx plus b. Y is actually x, because we're moving on the x-axis. M is the slope. We talked about the slope of the position graph is the velocity. So, the velocity in this case is 0.8 meters per second. On the x-axis is actually t, so we're going to take 0.8 meters per second and multiply it by t. And b is the y-intercept, which in this case is where we started. So that's going to be 1 plus 1 meter. And this formula right here will give you your position at any point in time along the motion from 0 to 5 seconds. So hopefully that all makes sense. You'll practice some more in the homework, and hopefully you'll understand. If you don't, you can always ask more questions and get some clarification in class.